Morning students, in this video we will discuss slip and its significance and rotating magnetic field concepts. So what is RMF? Rotating magnetic field. How will you get that rotating magnetic field? Once you give power supply to the induction motor. This rotating magnetic field concept related to stator, that rotating magnetic field rotation, that speed is ns equal to F by P. And slip and significance. What is that slip or slip speed? It's the ratio of slip speed to the synchronous speed, or a difference between synchronous speed and rotor rotation to the synchronous speed. Ns minus nr is the slip speed, ns is the synchronous speed of or rotating magnetic field of induction motor. This concept 3-phase induction motor. This topic is common for all the engineering branches, this subject. Okay, let's see one by one. First, slip and its significance. Slip is like is the ratio of slip speed to the synchronous speed. That slip is equal to ns minus nr divided by ns in percentage. Ns minus nr is the slip speed, ns is the synchronous speed. Okay, just I'll draw the I'll write the equation again. I'll not draw a diagram because diagram already we discussed. Ns slip is equal to ns minus nr divided by ns. Say ns minus nr in the sense slip speed, ns is the synchronous speed. Slip in the sense suppose rotor start rotating, difference between that stator magnetic field, rotor magnetic field, that is ns minus nr to the synchronous speed. So one like layer like structure, slip like structure. And its significance, if it is ns is equal to nr, or nr is equal to 0, so our ns is equal to, see, slip is equal to nr is equal to ns into 1 minus s, right? So if it is s is equal to slip is equal to 0, what happens? Ns is equal to nr, so it acts as a interlocking, or rotor slot is equal to stator slots, or stator and rotor magnetically interlock, jam condition. If it is slip is equal to 1, what happens? That is nr is equal to the rotor rotation is equal to 0, starting condition. Our motor is in still stationary constant condition, or jam condition also. If suppose if you give power supply to the induction motor, sometimes the rotor will not rotate. That time nr is equal to 0. If it is slip is equal to 0, right? So if it is slip is there, but slip is more than 1, what happens? nr is equal to rotation is in minus, right? And also slip is greater than 0, less than 1, that is motor. Slip is less than 0, that is generator. Slip is more than 1, that is braking region. That is the significance. Okay, and rotor induced EMF frequency, right? So Fr is equal to Sf, we need to derive now, because rotor induced frequency, when exactly will get? If suppose conductor, that rotor bar conductor cuts the rotating magnetic field, induces a current, that induced frequency. If it is stationary, there is no induced frequency, right? So if it is like rotor start rotating, induces EMF, induced current frequency is Fr. So percentage slip is equal to ns minus nr by ns into 100, and n is equal to nr is equal to ns into 1 minus s. Nr is the n in the sense that is actual speed of the motor. Okay, Fr is equal to Sf is the derivation for induction motor. Okay, next up there is a concept of rotating magnetic field. Before getting into that, we'll see how does this Fr is equal to Sf. So Fr is equal to Sf. Okay, S is the slip, F is the supply frequency, Fr is the rotor frequency. See, next there is a concept of rotating magnetic field. So here there is a supply we are giving to the stator, produces rotating magnetic field, and also we are going to check resultant magnetic field if it is omega t is equal to 0 or theta is equal to 0, 60 degree, 100 degree, 180 degrey, right? So when we give power supply like this, rotating magnetic field will be creating in the induction motor. This is a rotating magnetic field, NS, 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 NS. This is circuit diagram for giving power supply to the induction motor, right? So if it is supply we have given like this, three-phase supply, that is omega phi r is equal to phi m sin omega t, phi y is equal to phi m sin omega t minus 120, phi b is equal to phi m sin omega t plus 120. We got the equation. So how does this induces current or induces magnetic field in the stator like this? Okay, this omega t is equal to 0, omega t is equal to 60, omega t is equal to 120, omega t is equal to 180. I'll show you how we are getting this value and all, right? This is a supply. So if you give power supply, three-phase supply to the induction motor, what happens? Induces current. Induced current, I mean that whatever the current will be flowing through that stator field winding. So stator field winding, what happens? Due to current, creates flux, that is in the terms of sine wave only, phi r, phi y, phi b. Okay, so those conductors are placed 120 degree apart each other. So R conductor, Y conductor, B conductor, right? See, case 1 omega t is equal to 0. Okay, so 0, and this is minus root 3 by 2 phi m, root 3 by 2 phi m. This is resultant flux given by, so 1.5, 2 times of root 3 by 2 phi m cos 30, this part. Okay, so the equations are phi m sin omega t, phi m sin omega t minus 120, phi m sin omega t minus plus 120 or minus 125 b. Okay, minus 240. This is plus 120. Okay, so this is omega t is equal to 0, case 1. Only case 1 I explained, but you can do case 2 also. Okay, case 2 is like omega t is equal to 0, omega t is equal to 160 degree, omega t is equal to 120, omega t is equal to 180, likewise. Okay, so like this we'll get the vector diagram. I'll show you now. Like this we'll get the vector diagram for all the conditions. Okay, this is for one condition, this is for another condition B, and C is another condition, D is for another condition, right? So this is the concept of rotating magnetic field. Again I'm telling you that rotating magnetic field, the resultant flux phi m, 1.5 times of phi m, this phi m. Okay, and also see, this concept is very important for the examination point of view. Concept of rotating magnetic field. If you give power supply to the induction motor, what happens? Stator carries a current, stator field winding carries a current, that field winding is carries a current. What happens? Induces flux. That flux rotates at a speed of ns is equal to 120 f by p. So when start rotating, so obviously rotor bar conductor cuts that rotating magnetic field, induces current. So current in a conductor placed in the magnetic field experience a force. Then the induction motor rotates. So this is the principle and also concept of rotating magnetic field, everything. Okay, thank you so much. Next we'll see concept of starter. Okay, how do you start the induction motor? How do you starter operates? Okay, so let's see.